In this video, we are going to learn how to solve the ratio of two negative factorials. Suppose we have two integers, m and n. If we have a factorial of the sort negative m factorial, the solution to this will be infinite. In simple terms, it stretches to infinity. But we know that from theory, n factorial equals to n times n minus 1 times n minus 2 times n minus 3 times the successive terms up to times 2 times 1, where n is a positive integer, which implies that n factorial is defined for all positive integers. But what if we have something of the sort negative m factorial over negative n factorial? The solution to this will be finite. In simple terms, it will produce a finite real number. But how do you get to that finite real number? From the general formula for the ratio of two negative factorials, negative m factorial out of negative n factorial equals to negative 1 raised to the power of magnitude of m minus magnitude of n times magnitude of n minus 1 factorial over magnitude of m minus 1 factorial. Let's have some examples to see how this general formula leads us to a finite solution. Suppose we have negative 2 factorial over negative 4 factorial as the ratio of two negative factorials, and we are required to determine their finite solution. On comparison, we can see that m equals to 2 and n equals to 4. Let's substitute for them in this. This implies that negative 2 factorial out of negative 4 factorial will equal to negative 1 raised to the power of 2 minus n, which is 4, times n, which is 4 minus 1 factorial out of m, which is 2 minus 1 factorial. And this will equal to negative 1 raised to the power of 2 minus 4, same as negative 2, times 4 minus 1, we have 3 factorial out of 2 minus 1 is the same as 1 factorial. But from indices, we know that a number raised to a negative power is the same as the inverse of that number raised to a positive power, which implies that for negative 1 raised to a power of negative 2 will equal to 1 out of negative 1 raised to a power of positive 2. But negative 1 squared is the same as positive 1, and we will have 1 out of 1 is the same as positive 1. So we have positive 1 times 3 factorial out of 1 factorial. Still from theory, we know that n factorial equals to n times n minus 1 times n minus 2 times the successive terms up to times 2 times 1, which implies that 1 times 3 factorial out of 1 factorial will equal to 3 factorial will follow this trend. 3 times 2 times 1 over 1 factorial is the same as 1. And this will equal to 3 times 2 times 1 divided by 1 is the same as 6. Let's conclude. Therefore, negative 2 factorial out of negative 4 factorial equals to positive 6, which is a finite real number, hence a finite solution. Okay, suppose we are given this problem. Example, simplify negative 5 factorial over negative 7 factorial. So we are given negative 5 factorial divided by negative 7 factorial. From the general equation for the ratio of two negative factorials, negative m factorial over negative n factorial equals to negative 1 raised to a power of magnitude of m minus magnitude of n times magnitude of n minus 1 factorial over magnitude of m minus 1 factorial. And on comparison, we can say that m equals to 5 and n equals to 7, which implies that negative 5 factorial over negative 7 factorial will equal to negative 1 raised to a power of magnitude of m, which is 5, minus magnitude of n, which is 7, times magnitude of n, which is 7, minus 1 factorial over magnitude of m, which is 5, minus 1 factorial. And this will equal to negative 1 raised to a power of 5 minus 7, we get negative 2, times 7 minus 1, what do we get? We get 6 factorial over 5 minus 1, we get 4 factorial. But from theory, we know that any number raised to a negative power equals to the inverse of that number raised to the same positive power. So this implies that negative 1 raised to a power of negative 2 will equal to 1 out of negative 1 raised to a power of positive 2. And negative 1 squared equals to positive 1. So we will have 1 out of 1, which equals to positive 1. And this implies that we will have positive 1 times 6 factorial over 4 factorial. But from theory, we know that n factorial equals to n times n minus 1 times n minus 2 times the successive terms up to times 2 times 1, which implies that 6 factorial and 4 factorial will follow this trend. So we will have 1 times, instead of 6 factorial, we will have 6 times 5 times 4 factorial over 4 factorial. And this cancels with that, and we get 6 times 5, which equals to 6 times 5, we get 30. Six times 5, we get 30. Therefore, negative 5 factorial over negative 7 factorial will equal to 30, which is a finite number, hence a finite real solution.